Today we are going to be investigating waves. We'll be looking at both sound waves and light waves. Go ahead and open up your physical science review packet and turn to page number 6. You will see that it says waves and light note sheet. Let's first answer these two questions. We will write our responses on your note-taking sheet. What do you already know about waves? Can you name the different types of waves that you're aware of? Do you know how vibrations allow us to hear things from a distance? Please record your answers now. Let's first begin talking about the different types of waves that we can have and what waves are. What is a wave? If you said that a wave is a disturbance that transmits energy through matter or space, you'd be correct. We have all sorts of waves here on Earth. There's physical waves, like things like water waves, but we also have microwaves or light waves from the sun, or we have the visible light spectrum. We also have sound waves, and we have radio waves. But how are these waves being transmitted, you might be asking? Well, that goes into part number 2. A medium. Waves transfer energy by vibrations of particles in a medium. So what is a medium? A medium is just a substance through which a wave can travel. Now, a medium may be a solid, a liquid, or a gas. Now, we talked about solids, liquids, and gases in our states of matter review. Remember that solids have particles that are tightly packed together, liquids have particles that have a semi-attraction to each other, and gas particles have particles that are farther apart, right, because they have low attraction. With this information that you know, I would like you to answer the question next to share in your note-taking packet. It says, how do waves move through different mediums? In other words, what kind of things do waves move through more easily? So if you were looking at a solid, a liquid, and a gas, which of these substances would you say that waves can travel through the easiest? And which of these substances do you think it would travel through the slowest? Record your answer in your note-taking sheet. Now that we've talked about mediums, let's talk about the 3 different types of waves we can have. One type of wave we can have is mechanical waves, and mechanical waves are waves that require a medium. Another type of wave we can have is seismic waves. And the seismic waves, the energy that travels through the earth. You've learned about this in 6th and 7th grade when you learned about earthquakes. So seismic waves are really energy that's traveling through the earth, and we know that we can have S waves or P waves. Another type of wave we can have is water waves. So if you've ever been to the ocean or to a great body of lake, you might see energy moving through water, and that is water waves. One thing to keep in mind, regardless of if it's mechanical waves, seismic waves, or water waves, all waves move outward from their source. So remember, all types of waves set up wave-like disturbances that travel away from the source. So imagine here that you have a droplet of water that hit a body of water, and you can see where the droplet hit. This would be the source, and then from there you can see that the wave is moving away from the source. You might use this same analogy on if you've ever thrown a rock into a pond. Remember that where the drop of water lands or the rock lands, the waves that are created move outward in a circular motion. The same thing happens when we have an earthquake, right? You have the source, the epicenter of an earthquake, and then those disturbances move outward in a circular motion. Let's talk about, in more detail, sound waves. Let's talk about how sound waves are perceived by us. So here we have sound energy. Remember, sound energy is transferred to us through vibrations that we hear. So if I click here on this drum, you can see that the source energy was the drum itself. And you can see that the drum then created vibrations in the air. And those vibrations in the air were then picked up by our ear. So again, let's review. An object needs to vibrate in order for sound to be heard. The vibrating object is called the source. So, in the example I gave you before, what is the source of the sound in this diagram? If you answered drum, you would be correct. Now let's look at this. The energy from the vibrating source is transferred through a medium. The medium in this example here would be the air. Once that medium transfers all the way through the air, it will then end up hitting our ear. Let's look at what happens once that sound wave hits our ear. The sound travels to the ear, and the energy is then transferred to the eardrum. So the sound traveled through the air, the medium of the air, until it hit our ear. Once it hit our ear, now that energy has been transferred to the eardrum, making the eardrum vibrate. Then these vibrations send a signal or message to our brain, and this is how we hear sound. So let's go back to that question I asked you earlier. How do waves move through different mediums? In other words, what kind of things do waves move through more easily? I'm actually going to give you the answer now. Sound actually travels the fastest in solids, things like rocks or wood or the earth. And the reason for this is because think about solid particles. Solid particles are tightly packed together, and this close packed solid ends up allowing the particles to move faster through them because the particles don't need to travel so far to send the message to one another. Now, the sound would travel the slowest then through something like the air. Why is this? Well, think about gases. Because particles are farther apart in gases, it is harder for the particles to transmit that sound through a medium. Let's look at this picture here as an example. Do you see these three boys? They're all listening for the sound of sheep running. Here, this guy, he has the medium of air, which would be gases. Here we have liquid, and then here is the solid earth. Which one of these boys do you think would hear the sound of sheep running first? If you answered the boy with his head on the ground, you would be correct. This is why if you've ever been to a track meet, this idea of sound traveling fastest through a solid and slowest through a gas is the reason that they use a gun with smoke at a track meet. Why? Because you will actually see the smoke before you actually hear the sound of the gun being fired. Why is this? It's because sound travels slower through a gas. Let's take a moment to review. How do we hear sound energy again? If you said A, you would be correct. And what is a medium? If you said B, you would be incorrect. If you said A, you would be incorrect. Because remember, a medium is a substance through which a sound can travel. How about these questions? These are on the bottom of your note-taking sheet. Take a moment to answer questions 1 through 4. First question, sound travels the fastest through. Question 2, sound travels the slowest through. Question 3, sound travels through a blank to reach our ears. And question 4, vibrations produce blank that move through a medium. So let's summarize sound energy. Remember that sound is made up of vibrations that travel through a medium to reach our ears. Sound reaches our ears via vibrations that are given off. The vibrating body is called the source. The medium is then where the vibrations move through. Remember that once the sound reaches our ears, our eardrum then begins to vibrate, and that this sends a message to our brain. And don't forget that when we're talking about mediums and sound vibrating through them, it can be a solid, liquid, or gas medium. We're now going to shift gears slightly, and we're now going to stop talking about sound waves and start talking about light waves. Let's talk about a characteristic of light waves. At this time, please turn your note-taking packet over where you see light waves on the top. And you should see an image with 2 glasses of water and a straw through them. We're going to explain why the straw looks like this. What's happening when you look at a straw in a cup or your hand underwater in a pool? Do you ever notice that your hand looks different underwater than it does above? that it appears like your arm is disconnected from your hand under the water, or at least slightly ajar? The reason this is happening is because of refraction. And refraction is the bending of light. And you might be wondering why this happens. The reason this happens is because light actually travels through mediums at different speeds, just like sound. Now here's the thing about light though. Light actually moves faster through the medium of gases or the air and slower through things like water. So as the beam of light enters the water, it actually slows down and bends. And as it re-enters the air, the light beam speeds back up and bends back again. And this is called refraction. Let's look at this in a little bit. If we look at this image here, you can see that we have a water jug and we have two bowls. One bowl has a coin in it and one bowl has a pencil in it. When we introduce water to the bowl, notice what begins to happen to the coin. Do you see how the coin appears to be larger underneath the water and smaller above? This is because of refraction. The same thing happens when we pour water into the bowl with the pencil. Do you see how the pencil appears to be off kilter? This is because as the light waves enter into the water, they actually slow down and bend slightly, which actually makes the image under the water appear a little bit different than it does above the water. So, is it straight or bent? Light is actually playing tricks on your eyes. The two items appear to be bent or enlarged because light travels slower through water than it does through air. So remember that when light enters the bowl of the water, it will actually slow down and change directions, and then when it leaves the water, it will then speed up again. And this is what makes items look bent. This isn't the only quirky thing that light waves can do. Light waves can also reflect. What is reflection? Reflection is when an image of light comes in and hits an object and bounces off. In your note-taking sheet, don't forget to define both refraction and reflection. And don't forget to give a real-life connection. A real-life connection that you could use for something like reflection would be if you've ever gone on a nice walk around a lake. The sun's setting, and as you look out on the lake, you can see that the sunlight is actually being reflected off of the water. Please notice when we look at things like reflection, notice that it actually bounces and then reflects in an equal and opposite direction. So this is called the angle of incidence and the angle of reflection. Now let's look at another property of light, absorption. Have you ever wondered why a carnation appears to be red or why a banana appears to be yellow? Well, this has to deal with the absorption of light. When light hits an object, the light will either pass through the object, be absorbed by it, or bounce off of it. So, examples of things that it would pass through would be things like a window or a clear glass. Things that it would be absorbed by, well now this is where color comes into play. An object will absorb every single color in the light spectrum that it is not. So if you look here at this flower, you can see that the flower is red. The flower will actually absorb the blue and the green light because it is not that color. The one thing that is then reflected off of the flower would be, or bounced off, would be the color that it is. So because the flower is red, it will then actually have the red light color being bounced off. Let's look at this in a little bit more example. So when I talked about things being passed through, this would be an example of light passing through a window, or light can be reflected like we have learned. But when it comes to light hitting an object with color, well this is what's going on. The apple will absorb all colors in the light spectrum that it is not, and it will reflect the one color that it is. So this is why an apple appears to be red. Let's look at another thing, which is the scattering of light. The scattering of light happens when gases and particles in the air actually send light waves in all directions. This actually explains the reason that our sky is blue. Why is the sky blue? The sky is blue because blue light waves are actually shorter and closer together, which means that they're more easily scattered by the air around us. So when light waves enter into our atmosphere, you can see that most pass through. However, the blue light waves, which are shorter and closer together, end up hitting the particles in the atmosphere and being scattered in all directions, which is why our sky appears to be blue. let's wrap up.